So let's get into this. So I am Susana Carrizal. I am the Net Zero Emerging Leader intern for Carleton Hart Architecture. And a little bit about myself is that I'm a third-year PSU architecture student. And the reason why I got into the Net Zero Emerging Leaders program was because growing up, I have always been environmentally conscious, mostly because of living in a place where pollution was very inescapable. And so that kind of got me interested in learning more about sustainable design and sustainable materials. And I kind of felt like having a hands-on internship will lead me into growth of knowledge for sustainability. And so my experience at Carleton Hart Architecture was full of discovery, learning, and problem solving that ended up me implementing a lot of the work within that 14-week short period of time. And it gave me the opportunity to work with data and energy modeling and seeing the firm's culture and workflow. And I really do want to thank the support of my mentors and the rest of the CHA team for making my experience at the firm exceptionally welcoming and full of growth. So going into a little bit about Carleton Hart Architecture is that they were founded in 1994 on their focus with supporting community building, specializing in affordable housing, and specializing focus in material health and equitable design approach. One thing that I would like to notice is that this is our third year reporting to the AIA 2030 commitment, and they started in 2018 with another Net Zero Emerging Leader intern. And I felt like that was a great opportunity for both of us to be able to learn a lot about what they're doing for the AIA 2030 commitment. Let's see. Excuse me for the technical problems. Let me click next for the next slide. There we go. So this is the sustainability timeline for CHA from 2006 to 2020. This shows the achievements of the green buildings over the years that include LEED certified green communities and Earth Advantage buildings throughout the years in Portland, Oregon. And next slide, let's see. There we go. So for the reporting year of 2020, I was able to report 17 projects to the DDX this year, and they were a mixture of affordable housing to commercial and hospitality projects. And as you can see, the target UI would be in the lower gray and the predicted UI would be in the orange. And I'll talk a little bit about why these might be a little bit different aspects, but as I looked into these projects, I began to be more interested in affordable multifamily housing and seeing what helps make the most impact to the predicted EOI. But I will talk about that in the upcoming slides. And first, let's look into the overall data of the 3 years that reported to the DDX. Oops. There we go. And so here you can see the average EUI reduction percentage. Here the percentage has been increasing over the years for the 2030 commitment, which is why in 2018 the percentage would be 38%, while the 2020 would be 27%. And even though it's going lower, us as a CHA projects are continue to be as a constant EUI throughout the years, giving the firm platinum to gold ratings in many of their projects, as seen in CHA's sustainable timeline in the previous slides. One of the things that CHA is, or one of the goals for CHA is to increase the number of projects that have 60% reduction. Since there has not been many of the projects with this amount of reduction, they are putting this into consideration for their future projects in the future. So on the plus side, many of the projects are getting modeled and giving the firm better feedback for predicted EOIs. or energy use, and making it easier to see where they are standing in the overall average. And the next slide. So by diving into 2 build case studies that use a third-party modeler, I was able to see the realistic view on how 2 affordable residential multifamily projects are doing. And so for these 2 projects that have the average of 39,000 square feet, they both serve an example to understand the affordable housing of CHA and their performances. So by having the third-party modeler as to show the as-built EUI performance, we were able to have an accurate number for the energy usage for these 2 buildings. And in our case, the affordable multifamily housing predicted EUI seems to look like it's underperforming, but based on our conversation with our third-party energy modeler, an EUI of 40 before renewables for affordable housing in this area is pretty good. So this is just the list of materials and systems used in both projects to help draw conclusions to my research and be able to kind of understand what types of materials were used in both of the projects and how they were performing. As I got into the breakdown of both of the UIs for these 2 projects, I was able to see exactly what was showing the most impact in the building's energy performance, which was water heater, miscellaneous plug loads, and heating. And in my in-house presentation, we discussed the best way to improve our energy performance is by working with consultants and optimizing the performance of the projects early on to maximize our energy reduction, which in this case are tackling plumbing, electrical, and mechanical. So now, besides my DDX reporting, I also wanted to learn more about building materials and how they impact human health. And me personally, I really wanted to dive into vinyl windows because it gave me a drive to find a different alternative, since I personally have been affected by the process in which many PVC materials are being made. And I also did realize that in many of CHA projects, many of the CHA projects use vinyl windows, and I wanted to see if there was an alternative way to be able to move away from that and be able to see the benefits of choosing an alternative. So first, I really want to dive into how PVC is made and why is it important for regular people and architects to kind of care about what harm can come out of creating a vinyl window. So one of the things that came to mind is the beginning process of vinyl windows, and that kind of starts with where it's being made in the chemical plants, starting with oil. And me living in an area like Pasadena, Texas, gave me a different perspective on how much harm can come out of materials like PVC, and it kind of just led me into like a realization that it leads to many health problems that led with me, myself, my family, and my friends. And so with that, I kind of believe that it's very important to know the life cycle of the materials that we are using. Chemical process of PVC kind of impacts the human health in many ways, but it mostly impacts, it really does impact the life cycle of the vinyl windows. So starting with the manufacturing process with creating the vinyl frame, and then the transportation process, and also going into how the window is being installed and it being handled by many of the workers, and then going into how it's being in contact with many of the occupants in the home. But the 2 major parts is how the vinyl is going into the landfill and how it's being produced in the beginning. So for choosing the vinyl, for choosing windows was daunting, and especially when there was a many frames to choose from. And so I ended up narrowing it down for 4 types that CHA would most likely use in their projects. And after looking up the performance, the cost, and harmful levels of these type of windows, I ended up narrowing it down even more to 2 of them, which is vinyl and fiberglass. So these two are the most practical windows that CHA are most likely to use. Since CHA is doing more of affordable housing, vinyl windows has been the best choice since they are really low in cost. But looking into other alternatives, I felt like fiberglass would have been a better alternative to go into rather than vinyl. But we'll see in the next slide to see how exactly that would be. So to draw a better conclusion, I ended up looking at one of the affordable housing project at CHA to see approximately how many windows are being used in a project. And the total windows was 167 with the estimated cost of $91,850. And by kind of choosing an alternative of fiberglass, the approximate price was 40% price increase. And that's kind of a really high price to be able to sort of put into an affordable housing unit, but kind of seeing the benefits of fiberglass can kind of counteract that and be able to maybe choose that instead of vinyl because of the 38% longer lifespan, the resilient to UV, it actually being recycled glass content, and have it be 9 times stronger and having a better energy performance than vinyl. So overall, I kind of went into all 4 of them and be able to create this chart specifically for CHA as a guideline to make an optimal choice when talking to a client. I was able to collect all the data I researched and create a simple to read visual chart and hope that they will be using during design phase to help make better choices. And to be able to kind of go into some of the resources you'll be able to see in my sources here, and that's pretty much all my resources. And let's see, I'm trying to go to the next slide. All right, and I just really want to thank Energy Trust and CHA for the opportunity for me to be an intern for this year, and I really appreciate everyone helping me out and the support that I got. Thank you.